In this video, we will be learning how set associative mapping is done. If you haven't watched the previous two videos of direct mapping and associative mapping, please go watch it for better understanding. Now, let us get into set associative mapping. So set associative mapping is going to amalgamate both the advantages of your direct mapping and then your associative mapping. Here the catch is split into k sets. Okay, it is split into k sets. It is based on how many values you can decide to have in a set. Then by using the concept of direct mapping, the elements or blocks of your main memory is placed into the set. This is where you will be using the feature of direct mapping. Inside the set, you will have the freedom to choose where the block has to be stored. It could be either in the first part of the set or in the second part of the set. In this example, we have two lines only. So this block 0, 0, 0, 0 could be either placed in the first line of the set 0 or the second line of the set 0. So here comes the concept of associative mapping. Here we are using k-way catch, that is the number of lines in a set. If you are using two-way set, then the number of lines in a set would be 2. If you use four-way set, the number of lines inside the catch will be 4. So here we are going to group two lines into each set. And this direct mapping concept is used where the elements will be placed into the either to set 0 or set 1 or set 2 and so on. Inside this set, you will be having the freedom to store either in the first line or in the second line of the respective set. This is where associative mapping concept is used. So it is an amalgamation of your direct mapping and your set associative mapping. So in this example, the same example I've used. Here your number of blocks is your main memory size by your block size, which is 16 blocks. So you will be using 4 lines for your block index, and the number of lines in the catch is catch size by your block size, which is 32 by 8, which is 4 lines. So you will be having 4 catch lines. When we have 4 catch lines, definitely we will be having 4 tag bits, which will be used for your finding out whether the data is present in the catch or not. This tag bit is one additional bit which will help in identifying the availability of data in the catch. Since we have used k-way associative, that is here let us take the value of k as 2. So it is two-way associative catch. We are going to combine two lines in each set. So the number of set is equal to number of lines by k. The k value is 2 because we are using two-way associative. So the number of lines of this catch is 4. 4 divided by 2 is 2 sets. So we will be having 2 sets, set 0 and set 1. In order to identify whether the block belongs to set 0 or set 1, we need bits to identify. So those bits are called as set index. Those bits are called as set index, as we have block index for identifying the blocks, catch index for identifying the catch, and tag bits. We have additional circuitry here which will hold the set index. Okay, because we have 2 sets here, only 1 bit is enough to either select from set 0 or set 1. Hence the set index is 1 bit width. Okay, now let us see how main memory blocks are mapped to the catch. The block index, okay, the value of the block index whose least significant bits are 0 will be mapped to set 0. So blocks 0, 2, 4, 6, 8 and so on will be mapped to set 0. Inside set 0, you can have either in this line or in this line. It depends. So there comes the associative mapping technique. Then those elements which have the block index which have the least significant bit value 1 will be mapped to set 1. Let us now move this block 3 into the catch. So this block 3 will be moved into the catch line which belongs to set 1 because the least significant bit is 1. Okay, it could be moved either to this or this. I'm moving it to the first line of the set 1. Okay, so now we have to fill up the tag bits corresponding to each line of the catch. So these 3 bits, okay, these 3 most significant bits will be taken as the tag bits. Yes. Now here we have moved block 1. Block 1 has the most significant 3 bits as 000, so it is moved here, and the block is mapped to the set 1. Now if the CPU gives a physical address of this 0001010, you will be discarding, you will not be considering the block offset now, because we have to first find whether the block is present or not. So we will be considering only the first 4 bits. This bit which is in between your block offset and your tag bits, since we have 3 tag bits, I am going to take only 3. This is used for checking whether it is in the set 1 or set 0. Okay, so it is 1, so it belongs to set 1. The block belongs to set 1. Now these 3 bits, okay, these 3 tag bits of the physical address will be compared with the tag bits of set 1. So here in associative we used comparators, many comparators, but here we will be using comparators based on the value of k. If you have k as 2, we will be using 2 comparators. So here 2 comparator circuits. So here this tag bit 000 is compared with the tag bits. Okay, first it will be comparing with 001 and then 000. Okay, so it is not a match. Next it will be comparing with the next. So it is a match for saying that your there is a catch hit. So that these 3 bits, tag bits, are compared and we have found a hit. Now we have 000 here, which is your most significant bit of your block index, and it belongs to set 1. So the address is 0001. And using this block offset, we have block offset 010. So the 010 will be used to identify a specific word inside the block. You have found when you find the specific word inside the block, it will be moved to the CPU for processing. This is how you will be working on set associative mapping. So the physical address which is used for identifying whether the block is in the catch or not is this format. You have the lower bits for your least significant bits for your block offset and the most significant bits for your tag bits, and the middle one will be your set index. If the set index, that is the k value, is 2, you will be using k values 2, you will be using only one bit, which is used to represent either 0 or 1. If the k value is 4, you will be using 2 bits, which is 00, 01, 10 and 11. And tag bits, it depends upon the most significant bit of your block index. This is how set associative mapping is helpful in mapping the blocks from the main memory to the cache.